Hello there! In this video, I'll be doing a deep dive into the mechanics of the moving object node-on, as well as a few other stuff regarding how objects move in Game Builder Garage in general. So this video isn't exactly a tutorial for a specific thing that you can make, but the stuff that I'll explain and delve into in this video might be important in any future videos that might involve the moving objects or object movement in general. So without further ado, let's begin. Here I'm just going to take a moving box, just make it zero gravity so that it doesn't move around. Then let's take a speed sensor, upper object, and a button. So right now the moving box is set to world and acceleration. So what will happen when we press this button here? So when I press that button, you will see that the instant I press the button, the speed goes up to 1 and then it slowly dies off. And if I hold the button, now you will see that the speed just continuously goes up as long as I have the button held down. So that's how basically the acceleration works. And next, for the speed setting, we do the same thing with on press. When I press the button, it goes to 1 for the first moment, and then it slowly goes down. But when I hold the button, it just stays at consistent 1 meters per second. And yeah, when I let go, it starts slowing down again. Yeah, so one thing before everything, speed sensor outputs its values in meters per second. So basically, if it says here 1, that means after 1 second, yeah, basically, the object will move by exactly 1 meter. So here, for example, if I press the button, this object should move from here to here within 1 second exactly. That's how speed sensors work. So that we have a much clearer understanding of how the moving object works. Well, this one sensor might be a bit too hard to follow. Like the numbers move a lot very quickly. Maybe we need to like stop time and see it frame by frame what's happening. So actually I made this setup already where we can do that much easier. So in this setup, I just have this moving box. It's the same as earlier. Here is set to acceleration. And just have a bunch of sensors to it and a bunch of different number saving stuff that helps us see everything that's happening frame by frame. Okay. So I'll show what this setup does first and help you understand what all of these mean. So let's take the earlier example that we had where we had the accelerate box and we sent a value of 1 for 1 frame. So let's try to understand what's being printed here. So first column is frame. So if you're not familiar, the game runs at 60 frames per second or 60 FPS. So what that basically means is the game only updates 60 times per second, and that's around 16 milliseconds. Yeah, so each frame takes 16 milliseconds, so the game basically only updates every 16 milliseconds. And nothing happens in between each frame. So what you're seeing here, the movement of the objects may seem like smooth, they're moving continuously, but if you slow it down, you would notice that, yeah, if you go frame by frame, it actually only changes 60 times per second. So by looking at the values frame by frame, we can see exactly what's happening with the physics of the object after each frame. Let's go back to the first example. So here, so the input is basically just whatever value I send to the moving object. So in this example, I just press the button and it sent a value of 1. And as we saw earlier, when I send a value of 1, exactly 1 frame after, its speed will become 1 meter per second. So exactly the same as the input. In this next column, I have the speed, but it says m/fr. So this is basically just speed in meters per frame. So since we're looking at the movement of this box frame by frame, it will be much easier to follow what's actually happening with this column, since we can see the exact amount of meters it will move frame by frame by looking at this column. And this position is basically just the position of the object in the world when this was being recorded. So first, to make this analysis a lot easier, let's try to figure out how do objects lose their speed first. Let's go back to our initial example with a 1 frame of speed. So here I just have a moving object with an input of 1 for 1 frame. So it starts at 1 meters per second, or 0.0166666 meters per frame. Notice here that, yeah, every frame, the object loses some part of its speed continuously. So it happens every frame continuously. How much speed does it actually lose? Well, if you look at these numbers and do the math, you will find an answer there. So, but to make it much clearer, I will set to a different speed so that we can see the exact value. So here I just set the multiplier that I'm sending to the input to 60 for reasons you'll understand soon. But let me just send it for 1 frame. So here we can see that, yeah, the input is 60. In the next frame, the speed immediately goes to 60 meters per second. And the speed in meters per frame is going to be exactly 1. So since there's 60 frames per second, to get the speed in meters per frame, you just divide the speed in meters per second by 60. And yeah, that's exactly 1 meters per frame. Now here you will see something interesting. The speed that the object loses is a lot clearer now. So it looks like here it is around 0.1 meters per second every frame. So actually, in Gable the Garage, so it's not just moving objects, basically any object in the world, like even launch objects, they will lose 1/600th of their speed every frame. So what do we mean by that? For example, if your current speed is 60, if you want to know your speed in the next frame, or how much you're going to slow down in the next frame, just take your current speed, divide that by 600. So in this example, 60 over 600 is 0.1. Well, that's the amount of speed that you're going to lose during this frame into the next. So we see exactly showing here. From 60, it goes down to 59.9. And 59.9 over 600 is around 0.1 as well. So it keeps going down by 0.1 and so on. Let me set this to a different value to further prove my point. For example, the speed is 36. Here's 36. If you look at meters per frame, this is just 30. This is just the actual speed divided by 60 to see the value in each frame. And you can see here, for example, the speed is 0.6 meters per frame. 0.6 divided by 600 is 0.001. So from 0.6, it goes down to 0.599. And in the next frame, we take 0.599 and divide it by 600. So that's no longer 0.001, since it already went down to 0.599. So now it's around 0.00998. So that's why it went down to 0.598002 and not 0.598000. So yes, so as the actual speed goes down, the amount of speed that is the loss goes out as well. So it's always proportional to the current speed that you have. Well, now that we know this, we can actually make a way to make a moving object not lose any speed. Since we can figure out the exact speed that the object has and calculate in advance how much it's going to lose, well, we can just accelerate that same object by the amount it's gonna lose right now, so that in the next frame, when it loses that amount, we add that same amount back, so that those two basically cancel out and your speed doesn't change. Let me just show that briefly here. So for example, as I said earlier, we lose 1/600th of the speed. So the speed, so this is the speed sensor connected to the box. So just divide that by 600. So whatever comes out here is basically the amount of speed. So this is the current speed. So this is the amount of speed that the object is gonna lose in the next frame. But if we just add it back here, what will happen is when I press this button, in the first frame it's gonna be set to 36.6. And now normally after this frame it's gonna lose 0.001 meters per frame. But since we also added 0.001, 0.001 minus 0.001 is 0. So it basically cancels out. And now we have an object that doesn't lose its speed at all. That's basically all that there's to this setup. And if we want to shave a few more nodons, so we can actually do a constant division using a map. So if you have a map, set both inputs to 0, 1, 0 to 1, 0 to 1, and input range is basically the division range, and this is multiplication range. So if you divide, just set this to 600, and this just divides the input by 600. And yeah, you can do that in just one nodon. Oh yeah. In mind, this only works for acceleration setting. And you'll figure out later why it only works for acceleration setting. Now, you can finally analyze the speed of the acceleration. So the acceleration setting of the moving object is very simple. Example here, you can see if the speed is 0, its input is 2, it's just going to increase speed by 2 meters per second. And that happens for these 4 frames. So it goes from 0 to 2 to 4 to 6. The last one is 8. And then goes down. If we get rid of the this thing that we added and do the same thing, it's really the same thing, but yeah, each frame it loses that 1/600th of its current speed. So that's why at this point it's not exactly 8 meters per second. Since here, even when we're accelerating the object, so for example here, it was 5.99 and we accelerate the object by 2, it goes up to 7.99, but it also loses the speed. So that's why it doesn't end up at exactly 7.99 and also goes to 7.98 because the small 1/600th speed gets this subtracted as well. That's basically how the acceleration moving object works. So like for example, right now it's moving at a high speed, and if I set the multiplier to something to a negative value, it is the same thing. So like it's 14.98 minus 5, it just subtracts it, so it's 9, then 4, then 0, negative 5, and so on and so forth. Actually, one more thing, the slowing down of objects actually also applies to negative speeds. If I set to this, it's here, it's -1, and yeah, the same thing happens but in the negative scale. So it's basically just try to slow the object down back to 0, regardless of it's going negative speed or positive speed. Now, let's try to understand how the speed moving object works. So if we take the speed moving object and try it again, well, here if we just send a input of 1 for 1 frame, it looks exactly the same as the acceleration nodon. But if we hold 1, instead of going higher and higher, here it just stays at a value of 1. Simple enough. And then now that it's right now it's slowing down, you can see here me printing out the values live, slowing down. when I press the button again, like here, 0.29, after it sees the input, 1 and 0.29, it goes back to the input speed. Now, you might think that what the moving object does when it sets speed is that it sets its speed to the input. Now, that is kind of right, but not exactly right. Because let me give you another example. What if it's moving at 10? So I have speed is going to be 10, or it's going to slow down a little bit. But what if it's moving at 10? Then I send a negative input to it, like that, like that. Then, well, if the assumption is that the input sets the speed of the object to the input, that's not what's happening here, because at this frame, the speed of the object is 5.58. And when we send a -1 input, it actually just goes down to 4.57. And it goes 3 and 2 and so on. And only when, for example, here, the speed was 0.05, you send -1, it became -0.95. Only then, the frame after, did it actually reach the input value. So what's going on here? Well, actually, this is exactly the same as what the acceleration setting was doing. Like for now, right now, if it's accelerating -10 quickly, then we send a bunch of 2s to it. You can see here, yeah. If you just look at this first part, it looks exactly the same, or it works exactly the same as the acceleration setting. So if it sees -7 and 2, it adds 2, and 5, and -3, -1, and 0.77. But when the the calculated speed, so like for an acceleration object, if your speed is 0.77 and 2, and the input is 2, it will try to accelerate to 2.77. But what's happening with the speed object is, if it basically acts the same as an acceleration object, but if the next speed is greater than its input, it's not going to go over that. So for example, here, since the speed is 0.77 and input is 2, it tries to accelerate it to 2.77. But notice, oh, my input is 2, 2.77 is greater than 2, so let's just accelerate it up to 2. Let's don't accelerate anything more than that. And then in these instances, yeah, it sees that, or the input is 2, speed is 2. Well, normally it would try to accelerate to 4, but that's greater than the current speed, or that's greater than the input. So let's not accelerate it at all. Or if anything, it's just going to accelerate it. It's going to see that it's going to slow down by like that small amount in the next frame. So it just accelerates by that much. So it doesn't go over. So now, if we look at what happens when we set the speed to like a high number, for example, 20, and then what will happen if we send a speed lower than 20? So let's just send 5. You will see that the speed is 14.33 and input is 5. Speed basically works. It's basically acting as if it's receiving no input. And that is because, as mentioned earlier, the speed setting is basically just an acceleration setting that doesn't try to go over the input. So what's happening here is, Well, its speed is 14.33, so it's positive, input is positive. So it tries to accelerate the object to 19. But notice, oh, 19 is greater than 5, so we're not gonna accelerate it. It's already reached the speed that we want. So that's why even if we send it a value of 5, or even if there's a non-zero value here, the speed doesn't change at all because it's already, like, it thinks that it's already reached the speed that it wants, so it doesn't accelerate it at all. Because if the input is positive, it only knows how to accelerate things. That's why it doesn't set the input to 5, and it just ignores the input entirely. And when, like, if we do have a positive speed and then we send a negative input, well, now it knows how to deal with this. So now, like, its target is negative 4 meters per second. It says speed is 7.68. Yeah, it just works like an accelerate setting. So like 7.68 minus 4, 3.67, or 3.68, and minus the small amount. And 3.67 is still, we still haven't reached negative 4, so it doesn't do anything there. Same here, it subtracts 4, negative 0.34. Then here it subtracts 4 again. And only then will the speed setting kick in and see that, oh, it's trying to accelerate to negative 4.34, but that's greater, or that's larger than our input of negative 4, so let's just cap it to negative 4. If you keep sending it negative 4, yeah, it's just gonna cap it at negative 4. So that's basically how the speed object actually works. It just works as an accelerate object, but it caps the acceleration at the input it gets. So it doesn't try to set the speed to the input. It tries to accelerate the object with the input, and if it goes over the input, it stops. So now we finally understand how moving objects actually work. Well, at least if there's nothing connected to them. Because, okay, let's see what happens if we connect. This is our original moving box. Send a input of 1. It accelerates by 1 meters per second. Makes sense. But if we connect, let's say, an identical moving box to the same box, no connections, so it's just gonna stay there. What would happen when we send an input of 1? Well, let's see. So for some reason, we sent an input of 1, but the speed of the two objects is now 0.5 meters per second. So the input doesn't actually set the speed of the moving object to what we want. So it doesn't actually like go into the settings of the moving object and then literally increases its speed by 1. That's not what's happening here. How moving objects actually work is that when we send an input to the moving object, it actually applies a force on that object that makes it accelerate at the given input. So what's the difference there? Well, if you remember your physics lessons, the equation for force is equal to mass times acceleration. Or if we rearrange it, acceleration is equal to force over mass. So for example, if we apply a force of 1 on an object that has a mass of 1, then the acceleration will become 1. If we apply a force of 2 on an object that has a mass of 1, then our acceleration will be 2. That's a simple equation. So how does this apply to moving objects? Well, when we send a input to the moving object, what the game actually does is the game applies a force which is equal to the mass of the object times our input. So for example, if we, let's say the mass of this object is m. If we send an input of 1 here, what the game will do is it will apply a force of 1m on this moving object. Now, since the mass of the object is 1, or is m, m over m is equal to 1. So that's why the moving object will accelerate by 1 meter per second. Now, if we send a input of 10, what the game will do is apply a force of 10m on this object. So what will happen is, if the force is 10m and the mass is m, well, the acceleration will be 10. So basically the same as earlier. But now when we connect an identical object to our original object that doesn't move, so there's just like a extra weight added to the moving object, well, the force that the game applies on the moving object is only dependent on the mass of the moving object itself. So it doesn't really care what else is connected to it. It just always assumes that the moving object is on its own and nothing else is connected to it. So when we apply a input of 1 to this moving object, well, the game looks at this equation, or the game applies a force of m on this moving box to make this moving box accelerate at 1 meter per second. However, in the actual game, this moving box has another moving box connected to it. So the actual mass of these two things together is now 2m. Because since they're identical, and if we're saying the mass of this object is m, then if we add 2 together, then the mass would be 2m. So now when we send an input of 1 and the game tries to apply a force of 1m on this object, what actually happens in the game is, well, the force is still the same. The force is still 1m, but the total mass is now 2m. So the actual acceleration that these two objects experience is now 1m over 2m, or in other words, 0.5 meters per second. Now that's the case if the two masses are the same. So if they're the same, the total acceleration just gets halved. If the mass of the second object is smaller, so like, for example, this small object, let's imagine this small object has a mass of 0.5 m, let's say. So if the mass of this object is 0.5 m, well then the force that's applied to the moving object is still the same. It's still 1 times the mass of this object, or the input times the mass of this object. So if the input is 1, the force is still 1m, but the total mass is now 1m plus 0.5m, which will be 1.5m. So the total acceleration will now be around 1 over 1.5, which is a little bit higher than 0.5, but still much lower than the original 1 meter per second that we have earlier. And let's see it here. You see here, yeah, speed is a little bit higher now since the total mass is much lower, but it's still not 1 since the total mass is not what the game expects to see. It's much heavier than the game expected. And then if we make this a really big object instead, then the total mass is now, well, the mass of this is greater than this, so the total mass is now greater than 2m. So the total acceleration that we can expect here will be much less than 0.5. And if you try that here, see here, yeah, the acceleration is now 0.18. So it's more than, or less than 1/5 of the original. With this, the mechanics of the moving objects are still the same. So if we like hold, so let's change this to a accelerator mode first. So it's the same. The only thing that's changed is the acceleration that the is being applied on the objects, but the behavior is still the same. So like you can see here, when we send an input of 1, it still applies that same force. The speed just doesn't increase by 1. Instead, it's now increasing by the actual acceleration based on the total mass of the system. And that's what you see here. And yeah, it'll still keep on increasing as normal until it reaches the speed cap. Now, when we switch over to a speed moving object, it's the same thing. When we press the input for 1 frame, or like for a few frames, it works the same as the accelerator object. It just accelerates normally, or it just pretends that it's an accelerate on the accelerate setting, and it only changes once it reaches the target input. Now, one curious thought you might have is, well, now with my speed moving object, why doesn't the speed actually reach the target input? Because if you recall from before, when it was alone, the object was able to reach the specific input when we hold the speed moving object. Well, recall, since every frame objects actually lose a bit of their speed, for speed moving objects, when we're already at our target speed and we send it an input, it doesn't actually send nothing here. So it's not. So at this point, the input is actually still accelerating the moving object. But all it's doing is the game is calculating how much speed is the moving object gonna lose in the next frame. It calculates that, then it figures out how much force it would need to apply to make sure that the speed of the object stays at 1. So for this specific moving object, that would be like, yeah, there's going to be a specific value of force that the game will figure out that it needs to apply here so that this object will stay at 1 meter per second. Now, when we attach another object to the speed moving object, well, now it still assumes that the object is that small object. So, like when it's about to go, when the speed is about to go past 1 meter per second, it sees that, oh, because of the speed calculation of how the speed of the object is going to slow down, I need to apply this amount of force on this tiny object so that it will stay at 1 meter per second. But now, since we have a bigger mass attached to the object, that small amount of force is not enough to push this object towards 1 meter per second. Like the calculation that the game makes to cancel out the slowdown of the moving object is a little bit smaller than it was supposed to. So that's why here, whenever there's an object connected to another moving object, even if you set it to the speed setting, it won't actually reach the target speed and it will only get really, really close to it. So one last thing to keep in mind with regards to connecting objects to moving objects is that the calculation of mass in GBG is very weird. It's very non-intuitive. So, for instance, if the two objects are the same size, it makes sense that yeah, they have the same mass, and therefore will have, well, if you connect together, the total acceleration will be halved. So this is also true if they're the same object shape, but have the same volume. So for example, the x is 2 and the y is 0.5. Well, the shapes of these two boxes are different, but their volume, so the volume of this is 1 times 1 times 1 is just 1. However, this one is 2 times 0.5 times 1, which is also 1. So their volume is the same. And if we try this, it's still half. So at least that makes sense. If the volume and the shape is the same, the mass is the same. However, if we try to change the volume of the different objects, so for example, if we change the size of this object to 3, so the volume of this object is 3 times the volume of this object. So in the real world, if the mass of this object is m, the mass of this object will be 3m. And if we connect these together, the equation will tell us that a is equal to 1 over 1 plus 3, or 0.25. However, when we try to do this, we will see that the speed is not actually 0.25, it's in fact 0.29. So this object is actually a little bit lighter than expected. And yeah, but basically if you have different volumes, you can't really predict how much heavier one object is compared to the other. So if you are trying to calculate how big your object is, or how much force you need to apply so that a certain group of objects that are connected together would be accelerated a certain amount, I would suggest to just experiment on it on your own, because it's quite difficult to figure out the exact equations for it. So there will be a video on exactly how mass is calculated. However, for now, yeah, just keep in mind that yeah, it's not intuitive, and you would need to experiment on your own to figure out the exact masses of everything. Now, one last thing we need to discuss about moving objects is the speed limit. So here we have a acceleration type object, and if we hold the speed input, it will keep on increasing until it reaches 100. So in Game Builder Garage, every object in the game has a speed limit of 100 meters per second. No object can physically go beyond 100 meters per second. Like here, we have a moving object that we're trying to accelerate beyond it, but it's limited to that. Even if we change the input of the moving object, like even suddenly increase it at 1,000, it's still stuck at 100 meters per second. So this speed limit applies to everything with the exception of teleported objects. So like even stuff like the head node on, if you ever made games with HUDs, if you teleport really far away, it will take the HUD a few seconds to reach you, and that's because the head also has a speed limit of 100 meters per second. So when you do that teleportation and you check, the head will actually move at 100 meters per second, trying to catch up to you. The same thing applies to like stuff like freesliders. Like for example, here I'm setting a value of 1,000 to a freeslider, and if we notice here, yeah, the slider doesn't move instantly, and the maximum speed that this moves at is also 100 meters per second. So it applies to literally everything. So in terms of here, so if we try to calculate 100 meters per second in meters per frame, that would be around 1.66666 repeating meters per frame. So what that basically means is that for any object, besides using teleportation, of course, the most distance that you can cover in one frame is It's actually 1.66666 meters. So that's the fastest that you can go. Anything beyond that will guaranteed be take you at least more than one frame. This speed limit also applies on the absolute speed of the object. So it isn't just a cap on the speed on each axis, but it's actually the actual speed of an object. So if you're familiar with vectors or how or movement in multiple directions is calculated, for example, if something is moving in the x and y direction, its absolute speed is the square of the speed of both axes. You add them together, then you get the square root. So basically here I'm just calculating the absolute speed of the object. And here I have a moving object that I set to move at 100 meters per second when I press certain buttons. So here's the x output and here's the y output for the speed. So let's just see it in action. So when I press A, it accelerates or it moves to the right at 100 meters per second. And I press B, it moves 100 meters per second going up. Now, if I press both, or I start with pressing A, then I press B, you'll notice that the speed actually goes down. And that is because of the absolute speed limit. Because if both X and Y speed are both 100 meters per second, if you do the calculation, the absolute speed of the object would actually be around 140 meters per second, since you're moving in more than one direction. Like if you draw the diagonal line, the actual speed there would be 140 meters per second. So that's why that doesn't happen. What actually happens is the game kind of corrects itself. Like it sees that it's trying to move up and to the right, but you're trying to force it to move at 100 meters per second, but it can't move that fast. So it settles on the values that would make it that will make it move at the max speed, which is 100 meters per second. So if you do the calculation, if you have speed in two axes, both are 70.71 something meters per second, the speed that you get there is 100 meters per second. So that's how it works. So if you are calculating the maximum amount of distance that you can cover in one frame, well, earlier in the one axis example, the answer was 1.66666 meters in one frame. If we wanted to move in two axes, then, or specifically at this speed, then the actual distance would then be 1.17 meters per frame. And then if you move in three axes, then the maximum distance would then be around 0.96 meters per frame. So that's the how the speed limit works when you're moving in multiple axes.
So one more thing to note about moving objects approaching the speed limit, if you try to make a moving box accelerate at a speed that will go over the speed limit, what it will do is it will still try to move in the direction that you want it to go. It will just scale down all of its speeds such that the total speed will be equal to 100 meters per second. So what do I mean there? So for example, if I set both inputs of the moving box to 100, the speed that we'll see here is 70.71. Now, if I change this, for example, to 50, now 50 and 100, well, here I just pre-calculated everything. So if the actual speeds of the object were 50 and 100, this would be the total speed. So as you can see here, the total speed will go over 100 meters per second. So what the game will do is the game will scale this down until it reaches 100. and it'll scale both of its inputs down to reach that value. And here I just calculated it here. So from 50 and 100, they will get scaled down to 44.72 and 89.44. So even though like they reach a speed limit, the ratio of each of its speeds is still preserved. So like originally, the y speed is 2 times the x speed, and when we come to the actual values that we'll see here. So let me just actually run it here, and you can see here in the real game, that's the exact values that I calculated. Here, the ratio between the two inputs are still the same. So yeah, even if we make it very skewed, like for example, 1 and 100, or make it a little bit bigger. So yeah, for example, 2 and 100, even though these are pretty small, the total speed of an object moving at 100 in the y and 2 in the x is still greater than 100. It's 100.02. So the game scales that down just a tiny bit, so that yeah, this number becomes 1.9999 something. I think it just got rounded up here, and the y speed went down from 100 to 99.98. So here, yeah, the this value should be exactly still 50 times larger than this value. You see here? Yeah, you see it's 1.99 something that got rounded up, and 99.98. So that's how the moving objects handles moving at top speed. So other stuff actually doesn't do this. Like other stuff just like they don't preserve the ratio between each of the speeds once you hit the speed limit. But for the moving block specifically, it does preserve the direction that you're going through.
So that's basically it for this deep dive into the mechanics of moving objects. I hope you learn a few things on this topic. And yeah, see you in the next video.